I'd like to now welcome our final speaker of the session, Dr. Susan Chomba, a social scientist with over 15 years of experience in governance, policies, and institutions in forestry, agriculture, and rural development in Africa. She works on climate change, land tenure, equity, vulnerability, and gender. Susan is based at the World Agroforestry Centre, also called ICRAF, in Nairobi, where she currently leads one of the center's mega projects, Regreening Africa, whose primary objective is to reverse land degradation by scaling up proven and cost-effective technologies across 8 countries in Africa. Susan is passionate about applying research to inform development and works towards bridging the gap between the two. Susan believes research is critical for transforming lives and livelihoods of smallholders in Africa, farmers in Africa, and the development interventions are most effective when they are informed by research and vice versa. So for our final speaker, please welcome Susan Chomba.
Thank you so much. So I'm going to really dig deeper about agroforestry and the role that agroforestry plays as part of nature-based solutions. And I was also asked to explore a little bit about the current evidence and where we have knowledge gaps. And just to mention, I'll start with the key takeaway messages, that agroforestry is a key practice that enhances biodiversity conservation, climate change mitigation, and livelihood outcomes, making it one of the most effective nature-based solutions for addressing the current global challenges that have already been mentioned in the previous sessions. Secondly, there are complex interactions between woody and non-woody components and agroforestry that need to be clearly understood. And therefore, as Karen Hall just mentioned, tree planting is not a simple solution, not in agroforestry and not in reforestation programs. That takeaway message is that we have more scientific evidence at landscape scale than at farm level on key aspects such as hydrological functions, biodiversity and climate change and agroforestry, but these really vary depending on the context that we are working in. And I'll be digging a little bit deeper because I work across 8 countries in Africa, from East to West Africa, and the context really matters. And when I talk about context, I mean both the biophysical context as well as the socioeconomic context of the farmers that we work with. Fourth message is that smallholder farmers are key stakeholders in nature-based solutions. The decisions of millions of these farmers shape agroforestry landscapes across the global South. And the fifth and last takeaway message is that smallholder farmers or even local communities are not a homogeneous group. Their rights to land and trees and their capability to effectively engage in different agroforestry practices can vary based on gender, age, caste, wealth, among other socioeconomic stratifications. And so when we are designing programs, we need to have that in mind and not assume that a community is a homogeneous group. So when you look at agroforestry, I'd like to just give you an overview of this presentation. What is agroforestry? I know there are many people who are listening here and they are wondering, what is the difference between the talk that Karen just gave or Will just gave about forestation and agroforestry? What's the difference? And what is the potential for land restoration using agroforestry as a nature-based solution? What are the global goals that agroforestry can help us achieve? Where do we have evidence for agroforestry and where do we have gaps in terms of evidence? And the last point will be on stakeholder engagement and agroforestry. And so just to mention, agroforestry basically is where woody perennials, such as trees, shrubs, palms, bamboos, etc., are deliberately integrated in the same land management unit as agricultural crops and or livestock in some form of spatial arrangement or temporal sequence. And in these photographs that you see here, I give you just a snapshot of a few of the agroforestry practices. The photograph with the livestock is basically natural regeneration, what we call farmer-managed natural regeneration, where farmers deliberately manage trees and livestock in a single management unit. The second photograph with the woman, that's again natural regeneration in the West African Sahel. This is what we call the parklands. And basically you can see mature trees in the background and a younger seedling that the woman has marked and is taking care of so that it's not destroyed when cropping activities are happening. The photo on the bottom with the trees, young shrubs, with what we call the zipits or the half moons. These are soil and water conservation practices that are used especially in very arid areas to support tree growing, again, natural regeneration methods there. And the photo that looks quite familiar to many people of the papaya seedlings, that's the classic type of planting trees, fruit trees, that are then integrated with crops or even as a separate unit, in a temporal sequence. So this papaya plot, if you come here in maybe 2-3 years' time, the papayas will be removed and you'll have crops or livestock put in that system. So this is just a snapshot of how you can integrate the woody perennials with non-woody perennials with crops or livestock in the same management unit, either at the same time or at different temporal sequence. So when you look at agroforestry with that kind of complex systems, there are many kind of benefits, products and services that tree provide to the households. And these include energy, fuel, food. And that also has an impact in terms of the crop productivity per land unit and water, as well as the livestock productivity, and as well as labor productivity for households, and especially women who are the majority that are normally expected to provide fuel and to provide food in the rural households. And so the integration of tree components has a bigger impact at the household level. And when you look at the restoration potential for using agroforestry, this map is really a rough kind of an analysis, but credit due to IUCN and WRI in terms of looking at areas where you can really have what we call remote restoration, wide-scale restoration, and mosaic restoration. What you see as remote restoration, these are areas where there's basically very few human interactions in remote areas and where natural regeneration of forest occurs unless there are disturbances such as fires or livestock. And then the wide-scale restoration, this is where forest areas have been degraded, but the human interactions or human population is still very low. So you could restore these areas to close canopy forest over time. But what you see as about 74%, this is what we call mosaic restoration. And this is where you have human settlements and a lot of human activities. And that's where you have a transition in terms of how much you can be able to restore. And this is where agroforestry comes in. So it's a significant proportion of land area really that we are talking about in terms of the potential for agroforestry. And so when you look at what agroforestry can be able to play in terms of meeting the global goals of biodiversity, climate change, and livelihoods, I just produced this kind of a diagram to show the line, the thought of the mind map in terms of how you can start with the brown triangle or rectangle is where you have restoration of degraded lands with tree components. And with that, the tree components then help in terms of soil health and increased vegetation. And that has an impact on climate change mitigation because obviously you're sequestering carbon through trees. And then you also have increased agriculture productivity. And then you can also, through trees, you can have tree-based value chains, which provide income and job creation for youth, as well as food and nutritional security. So you can see that kind of linkages, how you can move from trees at the agricultural interface to other ecosystem services, including biodiversity, job creation, and food and nutritional security, as well as climate change. So where do we have evidence of agroforestry? As I mentioned, at the landscape scale, and this is just a snapshot or summary of evidence that I try to put in here. We see that the relationship between tree cover and water security is strongly contested, with palms versus sponges as key features of forest and atmospheric recycling as an arena of debate. And this photograph that you see here, the green arrows, this is showing you the sponges, basically the infiltration. The trees help with the infiltration of water, as well as enhanced flow of water into lower grounds, as well as pumping up the water up to the higher grounds. But also you can see that you have also increased evapotranspiration and blocking of water really when it falls on the tree canopies. So there's a very contested debate here in terms of the scientific evidence, in terms of whether trees really, the net effect in terms of the sponges versus palms is really beneficial. But what we have seen is that there's an asymptotic relationship between landscape tree cover and groundwater recharge. So this is what I'm talking about, the balance between infiltration and evapotranspiration in simple or the sponges versus palms. And these studies were done in West African parklands, where you see the asymptotic relation means that basically you have a curve that goes upwards and then levels up and then goes down. Then in terms of the relationship between trees and dietary diversity, again, you have a similar kind of a relationship. So you see, this is related to fruit and vegetable consumption, which increases up to 45% of tree cover and then decreases beyond that. Again, these are meta-analyses that have been done in Africa. So carbon sequestration, I've mentioned that because we are living at an era now where climate change is a major aspect, a major global challenge that we are trying to address. And in terms of agroforestry, again, this is just one of the studies that are quoted here. There are several other studies like Zuma et al. But this one shows the carbon sequestration potential of agroforestry system is estimated between 12 and 228 megagrams per hectare, with a median of about 95. And then in terms of looking at biodiversity conservation and agroforestry, again, there's no question about the role that agroforestry can play in enhancing biodiversity. But again, I think a lot of thinking goes through as agriculture is a major threat for biodiversity. But then we need to start thinking of how we can change agriculture into not just a threat for biodiversity, but as an integral element for sustaining landscapes, a force of conserving biodiversity and providing vital ecosystem services to local populations and securing livelihoods. So there's a need to start thinking about that. And I'll just demonstrate with the next graph here in terms of the role of agroforestry in biodiversity. So for mosaic landscapes, I say these are landscapes where you have a lot of human interactions and human activity, but you are also increasing the trees through natural regeneration methods or tree planting. The conservation value of agroforestry is really dependent on how much trees were left during degradation or deforestation phase. So this is what we call the forest transition curve, where you can start with primary forest, and then degradation and land and deforestation happens. And then you have agroforestry systems that are trying to either return those trees into the ecosystem through tree planting or natural regeneration. So the conservation elements of biodiversity of agroforestry is very, very much dependent on how much natural regeneration was left there in the first place. Then in terms of farm level interactions, I mentioned this is where we really have huge gaps. And I'm basing this one very much on my experience of interacting with smallholder farmers. Restoration using agroforestry is complex because there are many trade-offs and synergies. And I think this was mentioned very well by Karen. In terms of looking at how do you balance between the needs of crops and trees in terms of nutrients, water, and light. And there are times when you have competition between trees and crops, but also you can have places where you have a mutual beneficial relationships. So getting that balance right when you're working with farmers is absolutely critical. But also what we've learned is farmers have a lot of local knowledge about how trees interact with crops and soil, including how specific tree attributes affect these interactions. So it's not just about scientific knowledge, it's also about really making use of local knowledge by farmers. There are also trade-offs between economic or livelihood and conservation goals. Again, Karen mentioned that, and climate change mitigation goals. And I'll give you a very simple classic example that we deal with here. When you're trying to promote a tree-based value chain of some tree products, for instance, shea butter in the West African Sahel, and if there's too much removal of the shea nut, then you're really undermining the natural regeneration potential of the shea trees or the Vitellaria paradoxa that are really, really critical for that ecosystem. So you can really increase household income, you can have great value chains, but if you're not looking at the element of the seed availability and regeneration potential for the trees, then you could undermine biodiversity goals. So Generally, in general, farmers are looking for a land equivalent ratio of about that is greater than 1. That is where high productivity from trees and crops mixed together, than it's greater than when they are grown separately. Because you have what we call the niche differentiation. So for instance, trees and crops get resources at different times. So I'll give an example here with Fidelbia albida, which is again a tree that you're seeing in that photograph. That's a maize plantation in Malawi with Fidelbia albida integrated. And the beauty about this tree is that it has what we call the reverse phenology, where it sheds its leaves during the rainy season and therefore making really nutrients available to the crops. And you can see the green maize there as a result of getting the nutrients from the trees. And then it really develops its leaves during the dry season, again, when livestock possibly come into this system, and therefore the livestock can be able to benefit from shade, and it can really prevent livestock from suffering heat shock. So this kind of niche differentiation is, you've also seen the photograph that I showed, the diagram that I showed about trees being able to capture water from grounds that are far below where crops can be able to access. So in summary, where do we have gaps in evidence? I think when we are working across the 8 countries, and that's a map of the Regreening Africa program and where we work, East and West Africa, we get really a lot of questions by farmers. What's the optimum tree density that I should have in my farm, either through tree planting or through natural regeneration? What kind of species and genetic diversity should I be aiming for? These areas are areas of research that we clearly do not understand. What is the optimum soil health condition, and especially soil organic carbon, that a farmer should be trying to work with so that they're not only sequestering carbon, but also this carbon is available, soil organic carbon, obviously it improves the soil fertility. Again, these are areas that we could really do more research on. So there are aspects of agroforestry that I'd like to emphasize before I finish this talk. That agroforestry is basically, it occurs in landscapes that are constantly shaped by millions of smallholder farmers, and therefore they are primary key stakeholders. And as I mentioned, these are not homogeneous groups, and especially gender integration in restoration process, we found this a very difficult space to be able to navigate in. And this is precisely because in a lot of contexts, you find that women do not have access to or rights to land or rights to trees, and therefore they are not necessarily participating in these restoration programs. There are also state and non-state actors who may have different objectives for integrating trees in the landscape. And so we don't assume that everybody who's sitting around the table has similar objectives, but really what we need to know is to understand these objectives, and that sometimes they need to be negotiated. So for instance, if you set up a program whose primary objective is to sequester carbon, you don't necessarily expect that these local communities, this is also going to be their primary objective. Their primary objective might be livelihood outcomes, and therefore you need to have a negotiation process in terms of how you balance between the two. So we see that governance and institutions are also extremely critical. I've already mentioned the aspect of land and tree tenure. You know, we are working in places where rights to trees and rights to land are not necessarily secure or very, very clear in most cases, and especially so for women and youth. And therefore, engaging with government institutions who are the primary actors who can be able to revise these policies, negotiate policies, and tilt them towards disadvantaged groups is absolutely critical. Last but not least, scaling up requires strong engagement, not just with state actors, but also with non-state actors, and especially in providing economic and non-economic incentives. I think Karen mentioned here, which I'd like to emphasize, that it's absolutely critical to ensure that we are looking at ways that we can tax negative externalities, and then creating an economic incentive for positive externalities in terms of land restoration, and ensuring that these benefits are accruing to the right people who are the local communities who are working very hard to ensure that these landscapes are restored. So there's a whole reference list there that I provide. And with that, I'd like to say thank you very much. Do feel free to look at our website, www.regreeningafrica.org, for more information.